Just drove 60S for the first time, and it does have a lot more power, but on the other hand, I kept getting the P1439, I think subcode 41 or 42, one or the other, which is basically the IGBIT short circuit flag, which is sent from the actual power stage, which is inside of here, and then into the MCM. And one thing I realized when I got back is I didn't have the fan plugged in, so it's possible that, I mean, yeah, this is super, super warm. So it's pretty likely that we were actually just over temp, because I was pushing it kind of hard, so whoops. Anyway, so yeah, I got that a few times. It was always kind of at low end acceleration, so like 1200 RPM, you know, manual full assist. So yeah, right now I'm using a fixed voltage for this. So basically this pack voltage varies from around, at the very, very low end, 190 volts or so. At the high end, it's like 250 volts if you were at like 4.1 volt or 4.2 volts per cell or whatever. So right now I'm just always spoofing 170 volts, and LiBCM can only spoof from 67% of the actual pack voltage to what I just found, what I used to think was the pack voltage minus 12, is actually a function of the voltage. I wrote about that earlier. So I now have that code implemented correctly. There was another issue. There's actually a firmware bug with the MCM where if the V-pin signal going to the MCM is below 0.5 volts, then the MCM actually underflows, and so it thinks it has like 600 volts on the PDU side, so it won't actually engage the relay. Now, interestingly, when that underflow issue occurs, because the key-on voltage here is higher than the voltage of the battery, there's no check engine light until you try to start the car, but it never actually engages the relay. So you can sit here for an hour, like I have a couple times, and as soon as you get the signal working right, it will throw that relay without sending a check engine light. So kind of a bug on their, they had a few bugs in their MCM firmware. Now I have a whole bunch more on LiBCM, but this is actually a shipping, the MCM firmware is the shipping firmware from Honda, and it has some bugs in it. And they had a whole engineering team working on it, not just some dude in his garage. So anyway, there is that bug, and I fixed that. Basically now the minimum PWM value can't be less than 26 counts. So basically that's 0.5 volts on a 8-bit DAC. So that might have actually been causing a few of the I forget the code it throws, whatever it is. I think that might have been causing a couple of those issues. And then I also believe that I've resolved the P1576 issue. We'll see. So other notes with the 60S. One, regen is a lot less pronounced, particularly when the pack is more fully charged. And that's simply because the MCM can't generate a high enough voltage to charge the battery. So for example, when I drove down Lookout Mountain, which is the mountain I live on, I can typically regen brake the whole way down. But when you start with a full pack, I can't do that because the pack voltage is 230, 240 volts, and the flyback voltage from the motor, which is the no load motor voltage, it's just hard to get above high enough voltage to where you're actually charging the battery. So you can still regen, so I'm not saying you can't regen, but as that battery voltage creeps up to 230, 240 volts, it becomes quite a bit more difficult. So you are getting regen, it's just less. So say instead of 9 kilowatts of regen, you might be getting like 4 or 5, and that's simply just because there's not enough voltage headroom from the motor to charge the battery. The motor voltage is less than the battery voltage. So anyway, yeah, no, it is working. I'm gonna go to Home Depot tomorrow, just run some errands, see how well it works. I already know here that I probably need to stay out of the low end, high torque, low RPM, because that's causing the 1431 or whatever the error was I said at the beginning. But again, I had the fan unplugged, and this is very hot. So, for what that's worth. I could hear it trying to click the relays on, and I figured the fan was running, but it wasn't. But yeah, anyway, we're grid charging right now. This is straight 240 AC going straight here into our grid charger. I still haven't received those orders from DigiKey, so I'm still using this old busted diode that's not heat sunk. It's sinking about, I don't know, 4 watts or so. So it gets pretty warm. And that will hopefully be fixed before the end of the week. DigiKey did finally send that order. Yeah, that's 6DS. It's fairly quiet now that I have everything bolted down. It doesn't sound like a rattling tin can. One thing I'm going to do on the next version, next time I pull this out, I'm going to put a layer of foam underneath the tray, because you can kind of hear the tray kind of thud whenever you hit big bumps. And so having some, I don't know, 60 or 80 pound rubber underneath that will silence that. So anyway, yeah, we're at the point where I'm worrying about rattles on this. So not really. There's so much other work to do. Anywho, yeah, that is the firmware work. This does have a bunch of changes that retroactively apply to 48S. So as has been mentioned on the forums, even though I'm working on 60S right now, any firmware work that I do is making the 48S, the old 5 amp hour G3 and this new Fomaco, 47 amp hour. It's all the same code at the end of the day. So the work is getting done. As I've mentioned also, like, I'm just trying to get this ready for the meetup in Maryland next week, or actually, wow, it's in a few days at this point, this weekend. And I believe I've done that. We'll see how that, that 30-mile round trip to Home Despot tomorrow goes. And yeah, so anyway, it's fun. There is more power, but again, with that short circuit thing, I know we've kind of already figured that out as a community, where the pen, basically, it's a single line that goes high or low, depending on whether or not it's short circuited. I don't remember what the logic is. It's either high or low. And Peter has something already where we can either delay that signal or just prevent it from happening altogether. And it's possible we could do LiBCM as a man in the middle to that signal with 60S. Who knows? All implementation details. I'm really not worried about it. For now, I'm going to just avoid the 1200 RPM, 20 kilowatts of assist or whatever, whatever it is. And then one other point here is that right now with 48S, I've been using, before I hit 60S here, with 48S, I've just been using the don't spoof the voltage, because I need to rewrite all of that and it wasn't really working well. And some of the bugs I've mentioned online were causing that at these higher voltages. But I am going to now go back and kind of retroactively change the voltage spoofing code as well, now that I have the actual core hardware, the 3 hardware signals spoofing correctly. I'm going to go back and fix that so that hopefully it behaves a little bit better. And yeah, pretty fun to look on that gauge and see 220 volts, with a it says 157 volts spoofed, which I don't know why, because I'm supposed to always be spoofing 170 right now, but anyway, those are all implementation details. Yeah, as always, thanks for watching.